Great to be here. Yeah, I've been with LangChain since May. And prior to that, I worked in applied AI in the self-driving car industry, lots of vision work. Before that, PhD, Stanford, so kind of academic background, moving to applied AI. More recently, been doing a lot of work with language models at LangChain. Great to be here. I spent a lot of time recently looking at the new vision capability that came out with GPT-4V. And I've been building some applications based upon that and was happy to kind of share. Should I dig into the slides?
Let's do it.
Let's do it. I think the first framing point is kind of as Mayo alluded to, a lot of interesting documents have images. Here's an example of a blog that I really like, Clouded Judgment from Jamin Ball. Really interesting blog kind of on financial reports, particularly related to tech. And you can see all the tables in here are actually copied images from somewhere else. And there's lots of figures as well, graphs, pie charts, line graphs. So a lot of the information in this particular blog is not in the text. It's present in the images. So to have RAG applications that actually are kind of comprehensive for things like Mayo was saying, financial reports, McKinsey reports, interesting blogs like this, you really want images to be part of that solution in that picture. Now, like, how do you get them in there? How do you think about adding images to RAG applications? To date, RAG has focused mostly on text and more recently a bit of work on tables, but images are like a third big piece here. And I can walk through 3 different options for doing this. The first step is you have to take documents and partition out the different subtypes. So I've been using Unstructured for this, which is a pretty nice document loader. And it allows you to take a document and partition like the text elements, the table elements, and also dump the images. Works for PDFs and other types of documents. So if you have those 3 document types, the question is then what? So one idea is shown on the top branch. Just use an embedding that can map images and text into the same embedding space. So there are multimodal embeddings out there. So for example, OpenAI open sourced the clip model, which is one form of multimodal embedding that works on both images and text. It embeds them into the same space. So it can kind of interchangeably operate with images and text. For example, you have an image of a dog and text, this is a dog. You embed those. They both map to basically the same embedding vector. So that's cool. And you could take those, multimodal embedded documents, images and text, put them in a vector store and retrieve based on them. Same with normal RAG. You've just switched out your embedding model. So that's option 1. Now, option 2 and 3 take a different approach, which is this. You take your images and you just summarize them to text. So map them from the image domain to the text domain. And you can use a GPT-4V model to do that. And then all you're doing is you're embedding text summaries of images. And there's actually a number of different ways to store this, but basically you're storing both that embedded text summary of the image and the raw image itself. LangChain has a representation called the multi-vector retriever to do that. So it's basically like a doc store for the raw images and a vector store for the embedding summaries. And you retrieve based on those summaries, and then you have a choice. You can, 1, just return those summaries. So don't worry about the raw images. Just operate on text, right? That's this option 2 in the middle. Option 3 is you can embed the summary, retrieve based on the summary, but actually return the raw image and then use a multimodal LLM for the final answer. So that's kind of the third approach. And I'll kind of walk through the pros and cons. So the first approach, multimodal embeddings, if we had a really high performance multimodal embedding model, this is probably the highest ceiling. This is probably ultimately the architecture that people will use for this, because you're not losing any information. You're directly embedding images into some space, and then you're retrieving based upon those multimodal embeddings. The practical problem today is there just aren't many of them. There's Vertex from Google. There's OpenClip. We don't yet have like an OpenAI provided multimodal embedding model. The other thing I will say is that for a lot of the document types that we care about, we want to retrieve like graphs, tables, like complex images that like may be difficult with a multimodal embedding model. And I'll show some examples of that a little bit later. Now, the second approach, again, was just take your images, summarize them, embed those summaries. This is like pretty easy, right? You don't change anything about your common RAG stack. You're taking images to text, then they're just text chunks. Embed them like normal, retrieve them like any other text chunk. That's great. The con is it's like kind of lossy, right? Well, it could be very lossy depending on your summary. But you're mapping like a rich image into like a text summary, which may lose information, right? Now, the third approach is the one that I've found to be the most performant today, and I like this because you are simplifying the retrieval process because you're using image summaries and you're embedding those summaries. You're using those summaries as like your handle to retrieve the image, but you're still passing the raw image to the LLM for the final answer. So like to answer the question in the end, the LLM still has that full image, and there could still be some loss in retrieval, but as long as you get the image to LLM for the final answer synthesis, it can utilize all that information. I'll show some good examples of this shortly. Again, this is kind of like a summary of that last stack I mentioned. You take your documents, you split them into the types, you summarize the images along with text and tables. That's kind of separate. And you retrieve, you can see in the middle here, you retrieve based on those image summaries, but then you send the raw images themselves to GPT-4V to generate the answer. That's it. Simple. And LangChain actually already has a really nice thing for this called the multi-vector retriever. It works out of the box. Really, the only new things you need to add here, you need to, and I'll show you in the notebook, you do need to kind of do these image summaries ahead of time, and you need to do some processing of these docs to fit them into GPT-4V prompt. That's really it, though. The vector stores, you can use Chroma and any other vector store you want, along with this LangChain multi-vector retriever thing, and I'll show you how to do that. So anyway, I found this to be really promising. I'll show you some good examples. So, okay, I showed you that blog post previously, right? Here's a question you could ask. What are the revenue multiples and growth for like 3 companies, right? What I found is, here is actually the table that is retrieved for this question. And why is that? Look at this image summary down here. This is the GPT-4 generated summary for this image that you're using for retrieval, right? The image is a table comprising key financial metrics of 10 technology companies, enterprise value, NTM, blah, 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 blah. Like, it's really good. These image summaries can capture a lot of nuanced information in dense tables and charts. Great. So I'm pretty bullish on this approach because think about it, when this question's embedded, you're doing a search against these summaries. Look, the summary has NTM revenue, all the keywords you would want that relate to the question. You can then fish out that image, and this works. Now here is actually showing the final retrieval and answer synthesis. So this is actually pretty impressive. Question, what are the EV/NTM revenues for these 3 companies, right? I just showed you retrieve the table, and down here you can see the trace. We can look into this later, but I show you the trace here. Based on the image provided, so this is GPT-4V producing the answer from that retrieved image, which appears to be a table of financial metrics. We can extract the following information for these 3 companies. MongoDB, multiple 14.6, growth 17. Let's look up here, sanity check it. Okay, so you can't see the table headings, but I've sanity checked these and they're right. This first column's the multiple, and then this is the growth. So 14.6, 17. So this is non-trivial. Basically, GPT-4V is able to look at the table that you've retrieved look at your question, and then reason about the information you want, return granular table information to the answer. That's pretty cool. Now let's try another example. Here's like a more complex one where it's like, give me company names or interesting investments based on multiple and historical multiples. So kind of look at history and also look at current multiples, right? So this is pretty interesting. It retrieves that initial table of the company multiples, and it retrieves this historical trend of multiples. I show the trace down here. We can walk through in more detail later. The answer is like kind of hard to see here, but basically it gives you a pretty interesting assessment of like, based upon growth and multiples, here's the companies I like. And okay, you have to go to the trace to see like the rest of this, but basically the trace also talks about, in fact, I can maybe even open it up. I'll do this for fun very quickly. Here is actually the trace. So this is what actually got sent to the LLM. You can see it sends a few different images. Pretty neat. So it's retrieving all these images. Here's the prompt, by the way. You're a financial analyst. You'll be given a mixture of text, tables, and images. Use information to answer questions. Here's the question. Give me company names that are interesting based on multiples and growth. Consider historical. This is some text it gets to. Here's the answer. So this is kind of cool. It analyzes each image kind of independently. Okay, and it's like a very detailed answer. It tells you companies it likes. And right, it tells you information about the multiples. Yeah, we could talk through this a little bit more later. But I also thought it was interesting that there were some points about kind of historical trends. Well, okay, we can go through this a little bit later in detail. I'll just go back to the slides for now. But basically, it's able to look at this joint information jointly and provide some investments ideas based upon what you've asked for. This is another example. So this is kind of that first approach of using multimodal embeddings. I've tried this. I worked with the Chroma folks on this one quite a bit. The main point is that currently I have not found them to be good enough for retrieval of these complex things like tables and charts. It's more like it'll work for general concepts. So here's an application that I found to work for multimodal embeddings, but it's probably less relevant to more of like a finance or business audience. It was like basically an art critic AI. You have a collection of images, and it can look up images based on very general keywords. Like this is a very famous historical image from U.S. history of like a woman during the Depression in Oklahoma. And the keywords were woman with children. It can find this image. It can tell you about it. But again, this won't work. We talked about these like trickies of like very dense tables, charts. It's not going to be good enough for that. At least this current crop of multimodal embeddings, I'd be very skeptical. From my experiments, it definitely doesn't work. Maybe other people have found it to work, but yeah, so that's why this initial approach of multimodal embeddings I kind of don't quite recommend currently. This is just some preliminary evals. I'm going to do an updated evaluation. So this is kind of incomplete. This is a very small eval set. It does show that the approach we showed initially, this multi-vector retriever with image retrieval, but embed the summaries is the best. And the other approaches were 75%. Again, small eval sets, but I wouldn't take these metrics on face value. I'll be updating this quite a bit. But it gives you some intuition that this retrieval strategy, where you produce image summaries, retrieve on them, and then pass images to the GPT-4Z seems the best, especially for hard financial documents. Why don't I jump to the notebook? Mayo, anything to kind of interject right now before I kind of dive right in?
Yeah. So I'm, for people listening who might be kind of, this is a new architecture, right? That probably a lot of people are trying to wrap their heads around this idea of creating a summary of a chunk, right? So that the traditional RAG is you basically split and then you create the chunks of your text and then you embed those chunks, and the embeddings of those chunks It basically contains some document object. This is LangChain structure that contains the page content. So that's a chunk that's been split, and some metadata tagged onto that page content. So you end up with the embeddings, the page content, and metadata. So what you're saying is with this new structure, you're still doing the same thing, except that you're embedding the summary, not the entire chunk itself.
That's a key point. It's a very important general idea that decouple what you embed from what you ultimately want to send to the LLM. And to be fair, we came out with this kind of multi-vector retriever idea a while back in like August. It's kind of been around for a while. It's not that new. LlamaIndex put out something kind of similar, so like it's in the air. Other companies are doing a similar approach, but I think it's a general theme in advanced RAG is you can decouple what you embed for search from what you actually want to send to the LLM. And there's a lot of general instances of this. This is just one example, but you're basically trying to embed something that is well suited for retrieval, like a nice image summary that's plain language, simple, very easy to fetch, but then I want to send the LLM the raw image. You could do the same for text. Imagine you have a whole page of text, it's redundant, it's messy, create a nice little crisp summary, retrieve that summary, but then send the LLM the whole damn page with all the crap, it can figure it out. But you just want to decouple that raw image, that raw information that you want to send to the LLM from what you summarize or optimize for retrieval. That's a general concept. It happens to apply really well to this image problem, but it's a much more general concept. That's the key idea.
Interesting. So how do you identify, and I know you're going to go into the mechanics here, but how would you identify what parts of the documents are tables, what parts of the documents are images in a programmatic way?
Yeah, okay. So that's actually a really good point. And I'll show you the notebook here. That's actually where, to be honest, it is a data loading problem. And there aren't a huge number of good solutions out there as far as I have seen. So I've been using Unstructure, which is a really nice, it's kind of a very nice data processing loading package.
Mm-hmm.
This is in Python, by the way. And actually, you can see that command right here, where they have this partition PDF function. You can give it a PDF path, and you tell it, give me the images, infer the tables, some chunk parameters, and so forth. And this does all that magic. So this will split out your tables, and it actually dumps your images to this directory when then you can just read them back. That's what goes on. So this is where a lot of that magic happens. This is just where you then categorize all the text elements into tables text, and you read in the images later. So I've already run this, so I won't like waste your time running it again. But basically, the text chunks I get back, like this is what you're used to seeing, right? The whole bunch of text. I think this particular block doesn't have any tables, so this will be empty. So okay, it's basically empty. But this does work really well for documents with tables as well. So that's what's going on at the like document processing stage. Right. And then the second step here is the summarization bit. So this is pretty simple, right? This is just, you can call GPT-4 or any other model you want. We create a little summary chain here. Here's our summary prompt, no big deal. You're an assistant tasked with summarizing tables and text. Give me a nice summary. That's all that's going on here. You run the summary chain on your list of text and tables. You get your summaries back. Easy, right? That's all. Does that all make sense?
Yeah, that's
cool.
Yeah, that makes sense.
That's easy. Yeah. Now we'll take the same approach to the images. Here's where things are a little funny. And actually, I think LangChain literally yesterday, we just merged a better prompt template for images. So like this will be improved. This is kind of raw, right? But here's what's going on. For GPT-4V, you're specifying your model, Specifying max tokens basically tells you how many tokens to output. So it's like a parameter that you can supply. Now here's what's kind of fun. You can plumb in any image as a base64 encoded string. That's all that's going on here. This is literally from their docs. I just literally copy and paste the code. Here's how you encode the image. That's all that's going on here. Given an image path, it does this base64 encoding thing. This is just from the OpenAI docs. I didn't do any magic here. And you plumb it right in like that. Now here's the fun part. So again, we dumped our images previously with unstructured, right? We had our folder, just read them in, no problem, and encode them as base64 strings, and then generate the summaries. Now here's the cool part, right? Here's all the summaries. This image is a line chart, and I show the images down below, but basically this is summarizing all the images from the document. So we have this nice list of image summaries. Now we need to add these to a vector store. So our vector store, we're going to use Chroma, define our collection name. This is standard stuff. And then I have this little helper function that builds it. So I pass it in the vector store. I pass in the text summaries, the text, image summaries, images, and the tables. And all I'm doing here is, so this is where the magic happens. This LangChain multi-vector retriever is where you can pass it a vector store, and like this doc store is actually just like a key value. It basically is a dictionary that will store for every embedded document the raw document. So again, you're going to embed the image summary, and I can show you exactly where that happens. Yeah, let's see. I mean, so here's what's kind of going on. This vector store is our vector store, right? We're adding the summaries to the vector store, and then to the doc store, which is just like the raw documents, we add the actual doc contents. We link them with an ID, and we can look at the code later to actually see precisely how that works. But basically, intuitively, here's all that's happening. You have your summaries, you have your raw docs, define a common ID for each summary doc pair, store the summary in the vector store, embed it for retrieval, store the raw doc in the doc store, key value, just basic key value pair, and you have a common ID that you can use to basically look up the raw doc once you've retrieved the summary. That's all that's going on here. It's pretty simple. But this is doing all the magic, basically. We don't have to like write too much specialized code for this. And that's it. So now we have this multi-vector retriever thing that has our text, our tables, and our images. That's great. Here's where there's some like new and custom code to build a RAG pipeline that incorporates images and texts. The main new thing here is that what's happening is, think about like the simple case of RAG. You have a bunch of text documents, and you can just throw them all into the prompt, right, in like one place. For this text image thing, you actually need to construct the prompt really carefully because the images need to go in one certain way. So that's really all that's going on. All this code is basically just doing that. You're taking this mixed list, because now you're retrieving images and documents. You're basically like figuring out if a document's an image. It's a base64 encoded string, so you're trying to identify, oh, this document's a base64 encoded string. If it is, this is what's happening here. You are adding it to your prompt in one particular place, and then for all the rest of the stuff, like all your text, you're adding it in another. That's all that's happening here. It's like a little bit of code. We need to like, I'm sure there'll be better standards for this in the future. This is like literally my first shot at doing this. That's all that's going on though. Again, you've retrieved images and texts, and you're basically partitioning them up in your final prompt, because your images have to go in here and your text can just be added like normal. So that's all that's going on here. Does that make sense, Mayo? Just to maybe pause there for a second.
Yeah, I think a question that kind of popped up here is, so, most people are familiar with the idea of the embeddings of the text being stored in the vector store.
Yep.
So now we're dealing with images. First of all, we're not embedding the images, correct? We're embedding the summary of the. So where are we storing
Right.
we're storing the image in this doc store.
Yeah. This doc store thing. That's the key idea. That's the key idea. So here's the key point. This retriever thing, and I'll show you this right below. This retriever, here, actually, you know what? I'll show you an example that'll actually make this even more clear. So here's my question, right? Give me a bunch of companies of interesting multiples, all that. This is just a good old retriever, right? Get relevant documents. We've seen this a million times before, right? We run this, we get some docs back. Right, we have 4 docs, right? Now, here's where it's interesting. These docs now are a mix of images and text, because what happened is, it is true, we use those summaries to retrieve, but we've actually returned those raw documents. So the raw documents are this mixture of, it's a big text chunk, that's all fine. This is a base 64 encoded image. Looks like a bunch of gibberish, right? It's just, that's what it is. It's an image. And so that is exactly the interesting challenge. And you can see here, I have a little helper function to plot images. Boom, this is actually an image, right? So again, we've embedded the summaries. We ask our question. It'll find the most similar summaries. And then it'll return to you, not the summary, but the raw document, the raw image or the raw text. And that's what we're looking at here. That makes sense?
So the base 64 chunk, which you just showed,
Yep,
cannot be embedded.
okay, so that's a good point. No, not in any. Okay, so if you wanted to directly embed the image, you could use multimodal embeddings. Back to that prior point,
Right.
you could definitely do that. In practice, I have found that not to work as well for something tricky like a table like this. And it kind of makes sense, right? Think about it. Like, if you try multimodal embeddings on this thing, what's it going to map that to? Like, some high dimensional space where it has some notion of maybe a line chart, right?
Mm-hmm.
But it's probably not going to preserve all this nuanced detail of like, oh, EV over NTM revenues. It's just not going to know that nuanced information, most likely, in a multimodal embedding space. However, if you summarize this, you can get, as we showed before, a really good summary of like, this is a line chart of NTM revenue multiples over 3 different growth tiers. And that is very easily searchable just on text. You see what I'm saying? So our question, and you can see it's working right here. This is exactly what's happening. Our question was, give me company names that are interesting based on multiples and growth. Oh, and also something about historical. And probably it retrieved this image because it's like, oh, this is an image of multiples over time. There you go. Mm-hmm. But if you tried to directly embed this image with multimodal embeddings, I would be very surprised if you actually would then be able to retrieve this particular image from the question. Because I don't think multimodal embeddings will be able to kind of capture some of those nuances, like, oh, this is a line chart of revenue multiples. You might get a general semantic idea of this is a chart, but it won't capture as detailed representation as this is a chart of revenue multiples. Again, these multimodal embeddings have been trained more for dog, boat, cat, chart, general image concepts, not hyper nuanced chart information. See what I'm saying?
So in a way, we're moving to a future where RAG is a reference tool as opposed to a source of truth.
Well, I think that's what's kind of interesting. When you do the retrieval, you still do retrieve the raw information, this raw image, the raw text. But I think it's important to note what you actually embed for search can be definitely different, a different representation of this image, a summary that's very easily retrieved. It's like building a handle for this piece of content that's optimized to retrieve this piece of content. And we've seen a lot of approaches like this, a lot of different tricks to try to improve retrieval by like embedding a easier hook to get this thing back. That's all that's going on. Mm-hmm. And then, in the final answer synthesis, though, we're still using this complete image. And I'll show some good examples of that. So I think that's a very important nuance. And this is, I sanity checked this a little bit, like, why does this work at all? Here is our image, right? So this is like one of our images. Here's our table. And this is actually the table summary that we've embedded. This image is a table comparing key financial metrics of 10 companies, cash flow, EV, revenues, growth, all this. I mean, it even gets the watermark, right? This is really good. Like, this is really good for natural language retrieval of this table object. And that's the key point I want to hammer home. Now, the second key point, though, is we run RAG, and I'll run this live just to show it actually working. It takes a little bit because you're actually plumbing images to the LLM. And I can kind of get the trace ready to show. So I can pull up LangSmith here. I'll show the raw trace that we're running right now. Okay, boom, we have our answer. And I will show you, this is looking at LangSmith, okay? So this is the trace corresponding to this question. Give me the company names that are interesting based on growth and historical, right? I can actually open up the retriever and I can see, let's see where the chain is. Okay, yeah. So here's all the retrieved documents. Oh, it's going to be a bunch of base64 encoded strings. Even better, I'll just show you. I'll show you what the LLM finally sees in the end. So this is pretty neat. Here are the images that the LLM is actually seeing. Here's the multiple chart. Here's this like scatter plot of multiples. Here's our table. This is actually our prompt. You're a financial analyst. You're going to be given text, tables, and images. Use it to answer the question. Here's the question. Give me company names that are interesting based upon EV or NTM. So again, remember, we embedded summaries. We retrieved based on those summaries, but we're passing all that raw information to the LLM for the final answer. That's a very key point. That's very important, because now the LLM can reference all this stuff when it generates the answer. Now look at the answer. We'll scroll down. And this is a bunch of, by the way, we also pass text too. So this is like relevant text, right? Now here's the answer. It's like super detailed, but it's just pretty cool because the LLM can like reason about the different charts, right? The first chart, okay, the first chart shows multiples. The second chart shows growth. The third chart, we can see a few companies that have high multiples. They're highly valued. Okay, so it kind of gets that. It starts reasoning about this when considering multiples versus historical. It's important to note the first chart shows a peak. Okay, so it's looking at that historical multiples chart. It shows that COVID multiples bubble. So it gets that right, followed by decline. Well, multiples come down from their highs. They still may be elevated compared to historical averages. That's actually a valid point. This is getting kind of specific, but it is highlighting the trend from the first chart in terms of multiples. And given all this, here's a few companies that stand out to me. And it gives some recommendations. Again, I don't know if those recommendations are like really the right ones. You have to sanity check, but it's showing you the concept, right? You can actually retrieve this raw image information. LM can reason about it along with text and give you fairly reasoned answers. It actually gets these multiples. We should sanity check each one if they're correct. I showed an example earlier where it does confirm that they are correct. So anyway, it's looking at, here's a few company names that it likes based on multiples and growth. Here's your standard financial disclaimer. But again, pretty cool, right? That's what's going on here. So we've run this RAG chain. We've retrieved the raw images. We've embedded the summaries, retrieved the raw images, sent them to LLM. LLM processes them, produces an answer. That's what's going on here. I link the traces. And this is an image of what we just looked at. Here's some considerations, and maybe I'll pause there. It was like a lot of information. Like, Mayo, any reactions to that?
Yeah, I think one question that kind of pops up here is just kind of going back to this doc store again. Right. before, with the simple RAG, you're hosting your actual document text in
Right.
the vector store, right?
Right.
Now, so in this case, where is your in an actual deployed solution? Where is your text, or where is this base
Yeah.
or encoded image? Where,
Yeah, exactly.
where is it hosted?
So that's a good point. When I'm running this locally, it's in memory in a dictionary. Easy. In a deployed solution, this could be really any key value store. Chroma, I believe, actually has shipped with support for this doc store already. So it can be, I'm not sure exactly what Chroma's current setup is. But the concept is very general. It could be really any doc store that is connected to your vector store. So probably something like Redis, a key value store, would be very suitable, or something like this in like a production setting. And or I do think, like as mentioned with Chroma, more vector stores are going to ship with this kind of like external doc support. In fact, I worked with Anton from Chroma quite a bit on the multimodal RAG case, and this is explicitly something that they are supporting for multimodal RAG.
Right. And what about people who are using, say, other vector stores right now, like Pinecone, Weavit?
Yep.
Um, is there because essentially you're maybe people have applications running with other vector stores. How else can they create this doc store to
Yep.
integrate this?
Yeah. So the idea is it's super general. It should be compatible with really any vector store, because so if you look at this multi-vector retriever, um, I'll find it where we define it. Yeah. So this create multi-vector retriever, what's happening is you're passing in a vector store. So imagine this is any vector store you already have. What I think this is actually probably good action. What LangChain should add is the ability then to plumb in an arbitrary doc store as well. That's probably all that would be necessary, because right now we're actually using this little in-memory store thing that LangChain has defined as like LangChain storage and memory store. It's basically a dictionary. To support more production use cases for this idea, we would just need to support arbitrary doc stores like something like Redis, and that's actually a very good specific action that I will investigate. I'll make a note of that.
Right. Okay.
I think that is very doable, and that would unify the ability to run this like in a production setting for one. And also, two, the ability to run this with like an arbitrary number of different external doc stores, as opposed to, we have this default in memory thing just for like testing. But the principle is very general, because really all you're doing is you're defining a common key for every document. And like when you do the retrieval step, you have that key and you're just going to look up for that key, get me the raw document from the doc store. That could be Redis, that could be some other deployed thing. It doesn't have to be this in-memory thing. That's just a simple example we have. So the principle should be very generally applicable to all sorts of different document storage solutions.
Yeah.
That's a good question, though. Very good thing to highlight.
Cool. Yeah, you can carry on from where you stopped.
Yeah. Yeah. So, I think a lot of what I want to cover is kind of pretty well covered at this point. Again, maybe just to recap what we showed. So we showed that if I go all the way back up the stack, we have a document with a bunch of images. We want to ask questions about it. We want a RAG app that operates on images and text. We have a data loader from Unstructured that partitions images as well as the text. For every image, we generate a summary. For every text chunk, we happen also to do a summary. The same idea can be applied. Those summaries are embedded put in your vector store. The raw images and the raw text chunks are sent to a doc store. Every summary and every document are linked with a common key. We do retrieval. We retrieve based on the summaries. The summary returns a key. You use the key to look up the raw documents. You pass the raw documents to LLM. That's the whole thing. That's all that's going on here. We showed some traces where, yeah, so this is literally an example of, I asked a question. What was my question? It was, give me company names or interesting investments based on multiples and growth rate, right? Boom. Here's relevant images to that question. Nice. Table shows company multiples, growth rate versus multiples, historical multiples. Very relevant images based on my question, right? Pretty nice. Again, these all came from the doc store based on the embedding lookup of the summaries. Here's a text chunk. And I synthesized that into a pretty nice answer with specific companies referenced, the relevant multiples, some analysis, and all that. So, this is kind of showing the whole flow.
Yeah.
Here's a few other traces. They're in the notebook. We'll share the link to the cookbook. A few little points I found. Image size matters. Some of the code here, the reason why there's like a little bit of a chunk of code is it's really all the image processing and I found that resizing images is an important thing for like two reasons. You have to make them small enough such that they all fit within. There's some kind of non-obvious rate limits currently with GPT-4V. I know they say you can pass up to 20 megs. I haven't seen that in practice. I found that if I try to send in too many images, these are all small images too. They're like 100 KB or something. But I do get weird kind of like rate limit errors. So anyway, the point is I resize the images and I found this works fine. So I just kind of size them down. But I also found if you make them too small, then actually you lose important content. Like for something like this, where you're trying to get like granular information from tables, you need to be big enough to get the information, but small enough to actually like not cause rate limits. So that's kind of this thing I highlight here. Image size seems to matter quite a bit. The other little thing I'll flag, this is like classic RAG stuff, but you're doing RAG based on similarity to all these chunks, these summary chunks, right? If you're not careful about how you're also splitting your text, you can build lots of little text chunks that absorbs that similarity and prevents you from retrieving images, if that makes sense. So imagine you have like, an image summary that talks about, let's even look at one. We have an image summary here that talks about yeah, here it is. Look at this. So image summary talks about here's a table of multiples, right? So this is great. If we ask a question about like companies and multiples, we want this table back. But imagine in our text, what if we had like 10 little text chunks that all talk about like multiples, multiples, multiples? They might get retrieved over this summary of a very valuable piece of information in the image. So this is actually a really interesting like general retrieval problem that there could be a lot of different ways to address this. Like you could have maybe independent retrieval that looks only at images and like ensures you always return the top k equals 1 images. Anyway, there's a lot of ways to solve it, but the point is what I ended up doing is I built kind of larger text chunks, like 4K token text chunks. And I generate summaries of each one and I retrieve it based on summaries. And I found that works pretty well. You don't want lots of little text chunks that could absorb the similarity relative to the images, which you want to definitely return if you have a relevant question. Anyway, that's kind of like a nuanced point, but it's something that I found in practice matters to get these to work well. Which is, kind of true in any RAG application. You always have to think a lot about like your chunk size and how to retrieve, relevant chunks, how to not swamp the context window with like redundant chunks. So this is a classic problem, but in this domain it matters a lot because like you really want to get those images in if there's a apparently relevant image. So anyway, that's just a little thing to highlight. But yeah. Anyway, I mean, that's probably kind of all I had. but hopefully
Yeah.
it gives an overview of the idea and some of the pitfalls. I will flag, I'm still working on evaluations to really get that clear, but at least it shows you the idea. And there is a cookbook available. You can test it on your own data. And I'll also work on kind of building an end-to-end application that like shows this in like a compelling way. And
Yeah.
kind of go from there.
Yeah, just a few more questions at once.
Yeah, definitely. Questions are even better. Yeah.
I think you just touched on something, just your last point about the, kind of optimal split, kind of,
Yeah.
and it's like, based on what you're saying, is we still have to tackle the optimization challenges with regular RAG, because you
Yes.
we can't, this doesn't avoid the fact that you still need to find the optimal, for example, as you said, the optimal chunk size. So there is an aspect of this where when you were kind of presenting, and I was seeing an introduction to new parameters that I wouldn't have had to deal with before, I can see potentially people starting to work on this, thinking, okay, this is nice and this is useful, but now I have more parameters to think about what the optimal configurations should be. So you also had, like you said, the split. There's the split that I think I saw new parameters with regards to dealing with images as well, and
Yeah.
so there's kind of more variables here to look at, that it's kind of left to the developer to do extensive testing and figure out, what combination of these parameters would lead to the outcome they're looking for, and hopefully it's not too varied across different documents, because otherwise it just ends up being, you know there's no general purpose solution. It's like these types of documents or images require different optimal configurations to another one. So I'm just wondering what your thoughts are on that, in terms of, um, you know, what I guess, yeah, you did talk about evaluation, and that's going to be the next phase of helping with the
Yeah.
process, figuring out what's optimal.
Yeah. Yeah. I think the first thing I would say is that this is a moderate to like kind of advanced RAG approach. This is not the thing to start with. It is strictly more complicated than baseline RAG. So that's like the first preliminary for sure. Like this is something for people who have some familiarity with RAG, and it's more complicated. That's all there is to it. So that's maybe point one. Point two is, you are right. Let's just think about retrieval. All that's happening in retrieval is I have a bunch of text chunks. Some of them are summaries of images, and some of them are just like my text chunks or summaries of text chunks. And you're absolutely right. I still have the problem of like, I want to retrieve, the top N or top K that are relevant to my question. In this case, there's a little bit additional nuance of, I also would, now this is where, I don't know if there are great abstractions for this yet, but it's kind of like, I want to promote image content. Let me make it concrete. Let's say I'm doing top K equals 3 RAG. So I'm going to take the 3 most similar chunks. I have a whole bunch of text chunks and a couple images. Let's say my image is the 4th ranked similar chunk, right? So I have 3 text chunks. The 4th is an image. This is where it's like tricky, but I probably want that image to provide all additional context if it's still pretty close to my question, but maybe there's like 3 slightly redundant overlapping text chunks that are closer. Anyway, this is like classic kind of RAG diversity versus relevance stuff. There's a bunch of things to deal with this, like MMR, like maximum module relevance search. The hack I found in practice, or not really a hack, but I would flag that that's one big area to investigate with this in general. What I found kind of worked well is I basically create larger text chunks of 4K tokens, and I produce summaries of them. So I kind of map the text and the images all into this summarization space. I embed those summaries and I retrieve based on those embedded summaries. And I found that kind of somewhat balances between, like, if I do it the other way, imagine I have 5 images, but I had a very small chunk size. So I split the text into like 100 small chunks. I'd have lots of little sponges for relevance sitting around that could grab the top 3 and prevent me from getting images back. And I've seen that before. So what I do is I build big text chunks, I summarize them, and that kind of in practice works well, but it's a little bit hand wavy. I think that's a really good area for evaluation. The second point, and the final thing I'll note, is you do mention image size. That's one that I think I hope I can kind of like provide somewhat common guidance there with like one good set of evals. I think that's something where you can kind of tell people, look, if you're trying to retrieve information from like tables or like detailed figures, you need a minimum image size of something, and I'll try to work that out. Empirically, what I saw is I'm using like 1300 by 600. This is pixels. When I was down initially, I did something like more like 300 by 100. It was just too small. So I think that's one where like you can just give some general guidance to people, like, look, if you're trying to use images with GPT-4V for this application, just keep your image size above these values and just like kind of set that. I think that one can be like maybe one good set of evals, just kind of like clarifies what that should be for people. The chunk size thing is always going to be a little bit of a tricky one, though. So to summarize, I think the chunk size thing, always a little bit experimental. I'm using big chunks with summarization, and I found that works well. And the image size thing, hopefully, like one good set of evals can kind of set some good guidelines for people. So people don't have to like hopefully tune that one too much. But yeah, though, I think good question though, for sure.
Yeah. Another question here is the strategy here is different from normal RAG in the sense of there is no summarization. And so what I'm kind of wondering here is, you've got like a 1,000-page PDF,
Right.
and you're trying to, previously you would just take on the cost of embedding the chunks, and that was all you had to deal with as far as the model cost. What you're saying here is that you now have to take the additional cost of summarizing every chunk that you split effectively.
Well, okay, that's a very good point. You definitely, in this approach, at least approach 3, which I show here at the bottom, you definitely need to summarize all the images. That's kind of the way you get them into the right text space for embedding and so forth. How you deal with text chunking is actually still kind of up to the user and variable. I've found that this like larger chunk and summarization thing does work pretty well. That is not required though. In fact, initially I've also tried this with other approaches where, yeah, I don't bother with the summarization step. I just pass larger text chunks, and that also can work fine. So what I kind of call it here is this, like, creating larger text chunks and then also summarizing them are both up to the user. In fact, in this little generate text summaries method, I have a flag for do you want to summarize the text or not? Because I definitely recognize if you have a massive document with a large number of chunks, you may or may not actually want to summarize every one. I completely agree with that, which is why I take the approach. I create larger initial chunks, and I build summaries from those large chunks. But in this case, there was like 3 big chunks. So there's not too many summaries to generate. So I think that is something for the user to think about. And I think the particular thing I would think about is this. If I have a really big document with a large number of chunks and a small number of images, but I definitely want to make sure that image information can be retrieved, How do I ensure that? And this might be a case where a different retrieval strategy may need to be devised for much larger, like, for much larger cases where you may be doing an independent retrieval step on the images and then on the text, so that you always guarantee you get like an image back. Something like that might be more applicable. So I think that's like a good topic for future investigation. And I'll make a note of that. Would be for large corpus, separate retrieval for images and texts, so that you can kind of like guarantee if there is any image that's reasonably related, maybe by some minimum similarity cutoff, you get it back, and you don't get kind of competed away by a bunch of texts, if you see what I'm saying. So maybe we need a slight modification to the approach,
right,
for cases that are really, really large, where you have lots and lots and lots of text chunks. I think that's a very important point. It's kind of like with text retrieval, we have these ideas like MMR, max marginal relevance, to like enforce diversity. It's almost like we're trying to enforce diversity, but across modalities. You're trying to enforce that, like, hey, if you have a moderately similar image, you want to retrieve that because it's a very different modality and you care about it. You see what I'm saying? We might need some like better general methods to deal with like ensuring diversity across modalities. I think it's a very important point.
Mm-hmm. But what is the benefit of the, I mean, I understand you're saying there is the option whether to do it or not to do it, to summarize chunks or not. But what is the what is the benefit of summarizing the chunks? I mean, if you want to make that decision, what benefits do you get from summarizing chunks versus just embedding them straight?
Yeah, that's a good point. So there's actually one or two blog posts on this, which I can link. What people have found is if you perform a summarization step, you can avoid, and there's maybe two benefits. You avoid embedding a bunch of redundant or irrelevant text that's present in the document. So imagine, let's say we have a document, it's N pages. We want to embed like one page of the document. It probably has a bunch of filler text and other crap on that page that is not relevant really to the essence of that page that you care about in retrieval. So by building this compressed representation like a summary, you can get better quality retrieval than if you have that full document. It may contain spurious information that actually negatively impacts retrieval in certain ways. That's kind of high level intuition as to why summarization and then embedding the summaries can be a nice general approach for documents to improve retrieval quality. I would like to see evals on that, but that is one of the intuitions behind this. There actually is I will find it. There's some good documentation on this multi-vector retriever.
Got it.
Yeah, so this multi-vector retriever is kind of where in the documentation you can find a lot of, oops, I think I stopped sharing. Yeah, so multi-vector retriever is where you can see in the documents there's a lot of details on this. Let me find, yeah, so there's a bunch of options. It's not just summaries. Oftentimes a summary may be able to distill more accurately what a chunk is about, lead to better retrieval. That's the high level intuition. I have not seen full evals on that topic though, to be fair. So it's obviously critical in the case of images, because obviously unless you use multimodal embeddings, like image summaries are a very, very nice way to retrieve images. For text, intuitively, it kind of makes sense. It's a nice way to compress the content. But I have not seen evals demonstrably showing it result in better retrieval. But it does intuitively make sense. And I found in my case, it does lead to pretty nice results in this competing image versus text retrieval problem.
Interesting. And then just kind of, yeah, one more or second to last question here is
Right.
about advanced filtering, or kind of um, more like agentic behavior that more people are looking for. So, for example, maybe you want to the ability for a user to ask a question um, that requires some routing to a particular part of the where you store the embeddings. So maybe the person wants information specific about, let's say there's been some sort of earnings call, and they want to route to the parts of the earnings call discussion that talked about cryptocurrency, or talked about
Mm,
about the economy, for example. Um, but then maybe this document also contains images, right? I'm basically
mm,
saying the routing problem, or the filtering kind of of picking up in the intent of the question, figuring out what topic that is being inferred from the question, and then trying to route to the relevant section of information. How do you see that being combined with this architecture?
yeah. So the nice thing is that this architecture is entirely compatible with existing vector-based lookup, because you're mapping images into the text domain, and you're basically embedding and operating on these text summaries. So any existing tricks that you have for metadata filtering or other things you use with standard RAG would still work here on those image summaries. For example, like one of the most popular kind of tricks for RAG is this idea of the self-query retriever. The main point is that it can infer metadata filters from a user question and apply them. So like if a user question asks, like, give me Katy Perry songs from after 2017, it can infer a metadata filter 2017 greater than and apply that, given some information about the vector store. So the point is, we're using text summaries. It's just another text chunk. All the tricks we have for metadata filter and others would work here, no problem.
Mhm.
So I think that it's a very nice general approach to just use these text summaries of images, which then can be like processed in the same way that any other text chunk is. Things like metadata filtering would still apply, which I think is what you were kind of referring to when you said routing. Because routing is kind of a loaded term. Because sometimes when people say routing, they mean like, I have 3 different vector stores. I have a query. Tell me which vector store to hit. And there's also like, I have one vector store and I have like a document with different sections, like introduction, abstract, or that's a little bit more like metadata filtering. Like each of my chunks has metadata, like where it came from, and I can like filter for that at query time. Or so the metadata filtering thing would work entirely with this approach. There'd be nothing unique about that. The one thing that's a little bit tricky is like the user doesn't care and doesn't know what is contained in an image and what isn't. The user won't ask like, tell me about the multiples that are present in image in table in like image 4 of this document, right? That's like cheating. If they did, then okay. Imagine for every image summary, you had some metadata field that said image. And then whenever a user asks about images, okay, you filter for the images. That's easy mode. In the real world, that probably would never happen. You see what I'm saying?
Right.
I think that's unrealistic to expect. And so I think that really, first things first, for documents like I showed here, simpler documents, just kind of being wary of the competing text chunks, your chunk size is like step one. To ensure that you get a balanced mix. And then step two would be some specific engineering approaches under the hood, maybe on LangChain side or otherwise, to ensure that you're getting retrieval across modes. Like you get one image back and text chunks back. So there's like a separate thread of work that could actually focus on that topic,
Right.
which I
right.
think is entirely interesting. That's a great thing to look into.
Yeah, good point there. And
Yeah.
the last question is there, where does, because and I've seen some people showcase this, is instead of kind of treating the table as a table in the document, you basically programmatically take some sort of snapshot and turn it into an image and then use the image in the structure. So what are your thoughts on that strategy?
Interesting. Well, that's kind of a funny one because my initial sense is that's actually making the problem harder, because we could talk about this a separate time, but there are a lot of nice methods, maybe not a lot, but there's a few to extract tables and images from text. Those tables then, in fact, we put some stuff out on this, so is Llama Index. This same summary and like raw table retrieval thing works really great for tables too, by the way, not just images. Embed a table summary, retrieve the raw table, send the raw table to LM. That paradigm works entirely well with this same multi-vector retriever thing. That works great. Jerry from Llama also reported something similar. That's out there in the air. That works. We're extending the same idea to images here, but that's already out there. So I don't think you'd ever want to take tables, turn them into images, and then like make the problem harder. You don't have to process it in image. Keep them as text and tables. But maybe I misunderstood the approach.
That's a good point. I guess it's kind of, maybe the documents. I guess there's probably a way to try to solve the fact that sometimes you have large tables in these documents, um, and maybe if you then had a snapshot, then GPT-4 can infer based on the description. But as you said, there's new strategies to deal with embedded tables, so probably not a good idea to try and convert a table into an image and then deal with it that way.
My guess is okay. I think that my sense is it's actually making the problem harder, but I do think it's an important thing to flag. If you don't have a great approach for table extraction, it's a valid alternative. I've worked with an instructor for table extraction. It seems pretty good. There are some nuances where like it fails, like if you have multi-page tables. In those cases, though, I actually think creating an image would be harder. So I would stick to finding good table extractors, of which actually what we're using here, unstructured, works for tables. In fact, I include it in this representation just to show like tables also can be used here.
Good point.
So I don't think I would go from tables to images. I think that just makes the problem a little bit harder. Yeah.
Awesome. Well, I think those are the key points so far, and I know we're going to do follow-up videos in this, so I will look out in the comments and just feedback from the audience and reaction to this or any other follow-up questions, and that kind of inform us on the next step. So Lance, you did mention a few more things to come with evaluation. Is there anything else you wanted to mention?
Yeah. So evaluation is one we're kind of working on very actively right now. LangSmith is a platform offered by LangChain. We're building up public data sets right now. I think that's gonna be a very useful thing here to kind of put numbers to a lot of these approaches. I think is very helpful. I also think some simple applications that demonstrate this idea would be beneficial. Maybe I'll put something out, somewhat soon, just showing like kind of a multimodal RAG use case. Yeah, I think those are the two things: evaluation and then maybe like end-to-end applications. I think that those are two fun ones.
Awesome.
That yeah, absolutely.
All right. So thank you very much, Lance, and
Yeah.
see you soon.
Absolutely. Yeah, we'll talk soon. All right.